Okay, so this is going to be our second video of two for Algebra 2, Unit 3, Day 6. And in it, we're going to discuss combinations, which use what we saw in the previous video, factorials. So what are combinations? Right, so I define that all for us right here. So in math, statistics, probability, especially probability, combinations are collections of items chosen without regard to order, so it doesn't matter what order we choose things in, from a total number of things, right? And when we say that, we write it one of two ways. We say in choose k, or we write it like this: in choose k. Okay, so they both ultimately come down to the same formulaic representation. Um, in choose k is going to be n factorial over k factorial times n minus k factorial. And the notation here, regardless, we mean the same thing when we say n and k. So n is the total number of things that we're choosing k things from. Um, sorry, here, I'll just write that out. How many chosen? So we're choosing k things from an n total of items, right? So here's an example. And if you know me at all, you know I love Deadpool. So I'll give you a minute to read about this. If you want to pause the screen, go ahead, but I'm not going to read it. So, first thing we're asked is how many different weapon combinations are possible, assuming that he doesn't always carry his swords. Well, if he doesn't always carry his swords, then that means the total number of weapons to choose from is 8, right? And he can only carry 4 at a time, we're told. So k is going to be equal to 4. So we have 8 choose 4, right? And of course, referring back to this, that means we're going to have 8 factorial over 4 factorial times 4 factorial again, because 8 minus 4 is 4, right? So 8 factorial, 8 times 7 times 6 times 5 times 4 factorial. I'm going to stop there, just like how we saw in the last video. That's why, you know, we showed that trick. So 4 factorial, 4 factorial. So one of those 4 factorials cancels out. And we're going to have to keep on with this. So 8 times 7 times 6 times 5 over 4 times 3 times 2 times 1, right? And we know 4 times 2 is equal to 8. 6 over 3 is just 2. So we really have 7 times 2 times 5, or 10 times 7 is 70. Okay, so to answer number one, how many different weapon combinations are possible? The answer is equal to 7 times 2 times 5. In other words, 70 are possible. Right, so next example. What if he does always carry his 2 swords? Right, well, that changes the total number now, right? Because if he always carries his swords, then we only have his 6 firearms to choose from. So that changes n from 8 to 6. And that means k is now simply 2. Because if he already has 2 weapons, right, he can only have 4 at a time, right? So that means he's at 6 choose 2, right? And that, of course, is going to be 6 factorial over 2 factorial times 4 factorial. And we've got 6 times 5 times 4 factorial over 2 factorial, 4 factorial. That's going to cancel. We have 30 over 2 now, right? Because 2 factorial is just 2 times 1. So 30 over 2. And we know that there's 15 possible combinations, assuming that he always carries his 2 swords. Okay, and real fast, so here's some combination identities. Um, Pretty cool stuff here. Pretty useful if you can remember them, right? So let's go back to this last example. Or actually, I know we won't use those. We'll just make some up. So let's say I had 8 choose I don't know, 7, right? Well, 8 choose 7, and I shouldn't write it that way. I don't know why I put a fraction bar. 8 choose 7, we're here in choose k. 8 choose 7 is just 8 factorial over 7 factorial times 1 factorial, right? And we know that that's going to end up being 8 times 7 factorial over 7 factorial times 1. 1 factorial is just going to be 1, and we end up with our answer just being 8. Well, if I go ahead and do instead 8 choose 1, because 8 minus 7 is 1. If I do 8 choose 1, well, watch what's going to happen. I'm going to end up with 8 factorial over 1 factorial times 7 factorial. And we see this is the same 3 numbers that we're going to get, right? So we know our answer is just going to be 8 again. So anytime you have in choose k and you have another possible combination of in choose in minus k, try to say that 5 times fast, you're going to end up with that same identity, right? And we're actually killing 2 birds with 1 stone on this example, because this is the same identity as this last one here. So in choose 1 and in choose in minus 1, 8 minus 1 is 7, we see that we arrive at that same identity. So these kind of coincide with one another. And honestly, all the combination identities stem from that first one that I just showed you. Everything else is just kind of consequential to that. Not really including this one though. Okay, this one's kind of maybe hard to understand. So in choose 0. So let's say Deadpool still had his 8 weapons and he decided to choose none of them. He was just going to go barehanded. Real crazy and just karate fight everybody. Right? Well, there's only one way to choose those. So that's why we say in choose 0 is just 1. There's only one possible combination there. And because of this identity that we just saw, well, that means 8 choose 8 would also be equal to 1. So let's say he had some way to carry his 2 swords and all 6 firearms. Deadpool would only have one possible combination there, right? So this one kind of aligns with common sense. And again, it still goes back to this identity here. Okay, so that's all I got for this video, and that's all we're really saying for combinations. Like always, shoot me an email or come and see me if you need anything. Goodbye.